give us
So
16. So we should have
we're going to talk about these little area applications real quick.
over 3.
So here we
which
have
is exactly what we
random
got
function
on our calculator.
Kind of looks like a sun
So
curve.
that's super
Doesn't really
great.
matter what color.
Since we're looking at area, and
let's call this little dashed line
we just force it to be positive.
This little dashed
So our
line
area is going to be
equals
positive
B.
16 over 3.
And then we're going to look
units
at the area
squared.
in between
that would be
A
our
and
final
B
answer.
underneath this. Sorry that it's so congested in there.
So our
but know that
area
you can also do it on your calculator.
is going to be
Not a big
given
deal.
by
the integral from A to B
okay, and then
of
part
f
B,
of x dx. Okay.
so
A and B
from x equals -2 to positive
will be given
2.
in the problem.
So for this one, sorry, that's ugly.
My parabola. All right, so this is one type of question that they may ask you about definite.
And from -2 to
positive. Here is another type.
Is going to give us this shaded region right here.
Of
With part
question
of it
they may
above
ask,
the x-axis and
for
part of it
the
below
area.
the x-axis. So the point
bounded
where it switches is at 0. So now I'm
by f of x
intervals. I'm going to have -2
and
0.
the
I'm going to have positive
x
2. And those are all equal.
Okay. Now if they ask
and
for
I'm going to use
then
those
you're
as my
going to
boundaries
have
for
to
my
find
limits of integration.
these values.
So
the
now
roots
I'm going
of the
to
function.
write out my integral.
And we'll
First
still
I'll
call
have
them
the
x
integral from
equals A
-2
and
to
x
0
equals B. But in this case,
of
you
x
would be
squared
responsible
plus
for
4x
finding A and B by yourself.
dx.
And then I'm going to add on
my integral from 0 to positive
super
2
easy.
of x squared plus
Calculate
4x
the zeros. If it's
plus
not
dx.
function equal to 0,
the baby's up.
and solve.
Oh, not plus dx.
So our area
times dx
is going to be equal again to the integral from A to B of f of x dx.
She'll be fine for a minute.
And again, you will find
we have already conveniently done the integral from -2 to 0 in part A. And we know that that's just going to be 16 over 3, and we forced it to be positive because it was negative under the square
equation
root.
f of
And
x
then I'm going to go ahead and just tell you to do it on your calculator. I know that you guys
equal to 0 to solve for that.
Integrate this.
Okay.
Like
so
normal.
Those are two things.
So you would have 32 over 3 right here.
We're not done yet.
Okay.
There are two more things.
I'll go ahead and show you again
on
on
the calculator in case you just
the
want to
third
see it again.
thing
If you don't,
might
just
be asked.
skip forward in the video.
Will be to
find
so we would put the same function into here.
B,
second calc,
and C.
go down to number 7 with the integral.
Solving.
My lower limit is going to be 0.
F of
my
x
upper limit is
equals
2.
0. Well, okay, so we would that's how we would find our A,
a decimal.
I'm
so
sorry,
I'm
like jumping.
Click second answer.
Okay, so this
would
would be
decimal
our
again,
x equals A. This would be
enter
x
to get my
equals
fancy
B,
frac,
and this would be
and I get 32
C.
over 3.
And the question that you're
and then
asking is
obviously
you're asking,
pause if I'm going way too.
You're being asked to
when I
find
add
the
these
area
two things together,
bounded
32 plus 16 is going to give me 48
by f of x
divided by 3, and 48 over 3 happens
the
to be
x-axis.
Okay.
You may be asking
don't
yourself,
forget
what exactly does this mean?
This means this area
so that's
right
it for
here,
that problem.
And
I'm going to go ahead and pause this
right here.
Go
All
ahead
of that
and
stuff
try
both
2
by
through 4, and I'll
function
go through solutions
f of x and the x-axis. So we're looking for the sum of both of those things. Okay. Now, one thing that you'll figure out is that when you integrate and the function goes underneath the x-axis, it's going to be negative. So you're going to have to force it to be positive in order to find the total area bounded by those two conditions. Okay, so what we're going to do is first you would just like find this guy between A and B like normal. So we would find the integral from A to B of f of x dx. And we would be adding the integral from B to C. B, C, f of x dx. So in this particular case, and this might not always be the case, the one below the x-axis will be negative. And so you just have to fix that before adding them. And by them, I mean this piece and that piece, okay? You would have a function. So I guess, okay, so for this, maybe the area right here is 5, okay? And then I would want to add on the area here, but your calculator or what you calculate when you take this integral is going to be negative. You do not want to add those two together. It's going to give you less area than is actually there. So what you would want to do is you would say 5 plus 2, okay, to give you 7 square units. And I'll draw an example where this may not be true. So I'll do it right here. Okay. So maybe we would have a function that goes down and just touches the x-axis like this, maybe. And you would have a point there, there, and there. This is like a real thing that can happen sometimes. Sorry, the little thing is in front of the paper. And so in that case, you would have 2 positive areas and you wouldn't have to worry about it, okay? But that's not always the case. In this example, we would have a negative area. We just have to force it to be positive before we find our total thing, okay? And it'll be fine because you'll see the function. You'll know that you need to break it up into 2 sections, okay? And then the fourth and final thing that you might be asked for area is to find the area bounded by f of x and g of x. Okay, now, or I guess they could also say the area between f of x and g of x. Okay, so let's like color these guys so that we know exactly who's who. If you need colors, pause the video, go get some. So let's make this guy right here f of x. And then let's make this guy here g of x. Okay. And we are looking for the area right here. Okay. So now, instead of our boundary points either being like arbitrarily picked or being specifically a root, our limits of integration are going to be defined by our intersection points of our 2 functions. Okay. So in this case, our x equals a is going to be here, our x equals b is going to be here, and we would find a and b by solving f of x equals g of x. Okay, we're setting those 2 functions equal to each other to solve for those 2 values. Okay, and then our area will be calculated by integrating from a to b, and we would take f of x and we would subtract g of x from it. And we would do this because we want our upper function first and then our lower function. Okay, so this is upper minus lower. So basically what you're doing is you're saying, I'm looking at this area under the pink curve right here, and I'm taking all of this, which would include this little gap right here, okay? And actually, technically, if we went from A to B, it would be like all of this stuff like here, okay? And then we're subtracting off everything that's beneath this green piece right here. So we're only left with the stuff in between the 2, okay? Now you also may be asking, Miss Roberts, this part right here is underneath the x-axis, so it's negative, right? Yes, that is true. But when you take this and then subtract this part right here is going to have all of, like, basically a lot of this is negative. but we're subtracting it. So we're adding that stuff back on that we would have taken off right here. Okay, so the fact that we're subtracting some stuff that's negative is going to fix it. Just trust the system. It'll fix it for you and it'll work. So those are the 4 different ways that you could be asked questions about area. And then on the next page, we're gonna do some examples. I'll go ahead and do example 1 with you guys. And then also Gemma is probably gonna wake up any minute, so hopefully this example can go quick. So I'm gonna do example 1 with you guys right now, and then I think I might pause the video and make another section. And that way you guys can take some time and maybe try to solve it on your own, and then pick up the next video and solve through the rest of them with me. So this one says find the area between the curve y equals x squared plus 4x and the x-axis. And first it says from x equals -2 to 0, and then it says from x equals -2. Okay, so first, for part A, this is a quadratic. It has a positive leading coefficient, so it's going to open up, okay? And it happens to look something like this. It should have its intercept, x and y intercept should be at 0, because if I sub 0 in for either of these, I get 0, okay? Our values for part A are from -2 to 0. So -2 is going to be here, and then 0 is going to be right here. So we're looking for this area right here. Okay. So we would just jump right in, integrate. -2 is the smaller number, so it goes on the bottom to 0. X squared plus 4x dx. And then, so you could do this on your calculator. I guess I should show you how to do that. Or you could do it by hand. Of course, this one was so bad. So on your calculator, you would type your function into the graphing section. So click y equals, type in x squared plus 4x. And then you would go to second calc and go down to where number 7, where it has the little integral sign, and you would click that. And let's see, it asks for your lower limit first. Your lower limit is -2, click enter. Then it asks for your upper limit. Our upper limit is 0, click enter. And then it's going to go ahead and tell you that value. Now notice that this value is a decimal. If you are not happy with that decimal, quit this and then click second answer, and it will give you that value again, and then do the fancy frac thing, math, enter, and it will give you -16/3. I will go ahead and solve this for you so that you can see also how to do it by hand. So here we would go ahead and integrate. We would have 1/3 x cubed plus 2x squared plus c from -2 to 0. And then we would start off by subbing in 0, which is super convenient because all of it is going to end up being 0, 0, and then having plus c. And then we would subtract off everything with -2 in it. So we would have 1/3 -2 cubed plus 2 times -2 squared, and then plus c. Ooh, this is tiny. So you would end up being able to cancel out your c's right away. Okay. And then we would have, so -2 cubed is going to be -8, but then we have another negative here. So we would have +8/3. And then -2 squared is +4 times 2 is 8. That makes it negative, so -8. Okay. Now we get to do some fun fractions. So we want both of them to have a denominator of 3. So we have 8/3. And then we want to multiply this 8 by 3/3. 3 times 8 is 24/3. And then 24 minus 8